In this video, I'm going to show you 3 practice problems for how to graph an inequality and then find your solution region. So what I'm going to do is start with the first line here and graph this as if the sign in the middle was an equal sign. And so I'm going to start with, actually I'm going to rearrange my terms here and I'll show you why in a second. Normally we have our equation like this, y equals mx plus b. And so I'm going to start with first rearranging my terms because I noticed my slope term was second here and my y-intercept was first, but normally it's in this pattern. So just kind of to get your eyes thinking the right slope and intercept. So my starting point is -2 on the y-axis because that's my y-intercept. So I'm going to put that point there. And then I'm going to follow my slope, which is 3/2. So I'm going to go up 3, right 2. Up 3, right 2. And put a point. Up 3, right 2, put a new point. Up 3, right 2, put a new point. And maybe you want to start from that y-intercept and then continue that pattern going backwards. So down 3, left 2, down 3, left 2. And now I notice that this sign has a solid line underneath of it. And so I'm going to connect these dots with a solid line. So I'm going to use just kind of a straight edge to help me out. And there's my first line. Now, this is how you can know which side of your graph to shade. You can test a point like 0, 0. And so if I did that, I'd plug in 0 here. Is 0 less than or equal to? Well, anything times 0, if I'm testing this point, 0 would be 0. Is 0 smaller than -2? No, so we're not going to shade this side of the graph. We're going to shade the other side, which would be this region here. And then this is how my math teacher taught me. She said, looking at your y-axis, because we normally have these solved for y, she said, look at what's bigger. Is 8 bigger or is -8 bigger? And so she said, write the word greater up here and write the word less than here. And if my symbol is less than or equal to, I want to shade the side where the less than word is. So underneath of the line would cross. And basically, if I kept shading, right, I would shade that less than side. And that's how she taught me how to shade. Now, the second line, I'm going to do the same idea here, except I am going to rearrange my terms. So I have -x and +1, because it's a +1 here. So I'm going to start my new line at 1, and I'm going to go with my -1 slope, because we have -1x, down 1, right 1, down 1, right 1, down 1, right 1. Now, I notice that this line that I'm going to draw here does not have that solid line underneath of our symbol, and so this is going to be a dashed line. And so, you know, just maybe connect every other one or so to make sure you symbolize that it is a dashed line. Now this greater than, so I'm looking at this green line here. Ignore the pink if you can. It says greater than, so I want to shade the side of the graph where that word greater is, or you can always test a point like 0, 0. If we put 0 in, is 0 greater than 0 plus 1? Is 0 greater than 1? So no, we would not shade this side of the green line. So remember, this is our green line. Do not shade this side of the green line because of 0, 0. We want to shade the other side. So we're going to shade above our line. And what we want to look for is the double shaded region. And with colored pencils, that makes that pretty easy. So I'm just going to excessively shade my solution zone. I'm going to come back and get some more of this color in here as well. And the solution region is the double shaded region or any point on a solid line at that region. So this is our solutions over here. At this intersection would be not a solution because it also interacts with a dashed line, but anywhere past that on this solid line would work. No points on a dashed line would work, so that's also why that intersection doesn't work. But a point out here on the pink line would be a solution. So now what I'm going to do is actually talk about these 2 points, 4, 4. So 2, 4, 2, 4. So this would be a yes because it is on a solid line and it's on the boundary line. But a point like this would be a no. Even though it's on a solid line, it doesn't interact with that solution region. And then 3, -2, 1, 2, 3, down 2. This point is on a dashed line. And so no. So yes, because it's solid, and no, because the line was dashed. Okay, so let's do a couple more examples. Here's the next one. Graph the system of linear equations. First, what I'm going to do is solve my inequalities for y, just like we normally would if for y equals mx plus b. So I'm going to subtract 2x for my first function, and I have 2y greater than or equal to negative 2x, because I subtracted it over, minus the 4 that was already there. And now what I'm going to do to solve for y is divide every term by 2. So y is greater than or equal to negative 1x, and then minus 2. So I'll graph this line first, starting at negative 2, and I'm going to go down 1, right 1, down 1, right 1 for that negative 1 slope. And then I'm also going to continue the pattern from my starting point, that negative 2, going up 1, left 1. And this we're going to connect with a solid line. And greater than, this is greater on your y-axis, and this is less. And so I want to shade this side of my pink line. Or you can always test a point, like for example, if you plug in 0, 0, which is this side of the line, 0 is greater than negative 2, which means that's going to work for this side. And now my second line, I'm going to solve for y. So I'm going to add 2x to the other side. So I have then y is greater than 2x plus 2. So I'm going to start at positive 2, and I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And I'm actually going to continue that pattern going backwards. And this line is going to be dashed because there's no line, no solid line underneath there, so maybe connect every other set of points or so. You kind of decide. And then again, this symbol says greater, so as I'm looking at this green line, this side of the green line has the word greater. This side of the line has the word less, and so I'm going to shade this side of my green line over here. And then what we want to do is find that double shaded region, which is here and here. And just really, I tell my kids in class, like, just excessively shade that area. And I don't require this, but I like to write it down when I'm writing notes. Your solution region is here. So any point in that region or on this solid line would work, not the intersection of a solid and a dashed, because it interacts with a dashed. So here we go. There's a couple points here to identify. 0, negative 2, even though it's on a solid line, it's not at your boundary region. So no, outside the bounds. You know, like out of bounds. Then you're out. No, you're out. Okay. 2, 2, definitely no, because it does not interact with our solution region here. All right, maybe you want to pause the video now that I've done 2 full examples, or if you've watched previous videos, I've done about 5 now. And maybe you want to try on your own. So hit pause, graph your 2 lines, see if you can get your shading right, and then hit play and check. So this first line, I'm going to start at 2, and I'm going to go with my slope. Negative 3 is really like the fraction negative 3 over 1, so we're going to go down 3, right 1, down 3, right 1, down 3, right 1, and I'll do the same going backwards. This has a solid line underneath, so I'm going to connect these with a nice solid line. And now I write this word down to help me out, greater. This way goes greater as we go up, this goes less as we go down. So on which side of your line is the word greater, since that's my symbol here? This side says the word greater, so I'm going to shade this side of my graph. Sometimes it's even helpful to shade the word greater or less to kind of make that distinction. And then for the bottom line here, I'm going to start at negative 3 and down 3, right 1. And I can't go much more there, so I'm going to go up 3, left 1, up 3, left 1, up 3, left 1. Oh, that can be a solid line as well. Now my lines are not very straight. If I use a ruler like I normally do, you would see that they are exactly parallel. And then this says less than, so here's my green line. the greater than shows there, the less than shows here on this side of the line. So which side will you shade if you have less than? We're going to shade this side of our line. Now, interesting, your bounds don't interact. And so what would be at the same time greater than this line and smaller than this line? There is no solution region here. So there is no points that will work for both of those functions and be true, because they interact, and then the shading is opposite. One is greater, one is less. And you can't have something that is greater and less at the same time. That just doesn't work. So no points will be a solution. No points will be a solution because you don't have a double shaded region.